Hello students. So our today's topic is delta connection. In my previous lecture we have studied about the star connection and today I will start with the delta connection. Here this is the diagram of delta connection, how delta connection can be formed. If the start point and end point of one winding are connected with the start point and end point of the another winding, and a circular path is created, then it is called as delta connection. Here for this winding, this point is start point and this point is finish point, and this finish point is connected with the start point of the another winding. Clear? Similarly, finish point is connected with the start point of another winding. Therefore this connection is called as delta connection. And here we are having R, Y and B phase. Now all currents are represented here. This is current IR, this is current IV and this is current IY. These three currents are phase currents, and IR minus IY is line current, IY minus IR is line current, and IB minus IY is line current. How this current is written? At this node, incoming current is what? IR, and outgoing current is what? IY. So resultant current will be what? Incoming minus outgoing, so IR minus IB. Similarly at this node, what is incoming current? IB, and what is outgoing current? IY. So current will flow IB minus IY, and at this node, what is incoming current? IY, and what is outgoing current? IR. So IY minus IR. This will be your line current. So these three currents are line current. These three currents are line currents, and these three currents are phase currents. Now VRY is the line voltage. Similarly, VYB is the line voltage, and VBR the voltage between two lines. So voltage between B line and R line. Similarly, here the voltage between these two points. This is a phase. Again, this is a phase, and this is also a phase. So voltage between these two points, but I mean to say voltage of this phase is also equal to the voltage of VRY. Clearly, you can see that voltage between these two points is what? The voltage between these two points only. So in delta connection, line voltage is equal to the phase voltage. Line voltage is equal to the phase voltage. So this is the first condition. Clear? Now we will draw the relationship between line current and phase current. So let me draw the current phasor. If this will be your IR, then this will be your IY, and this will be your IB. Clear? Now what we have to do? We have to find the line currents. Clear? So first of all, let me draw this IB in opposite direction. So it will become minus of IB. Clear? And what is the resultant current in phase 1? In line 1, IR minus IB. So we have to find the resultant of these two phasors. So this will be your resultant, and it will be equal to IR minus IB. Clear? So let me write IR minus IB is equal to I line. Similarly, IY minus IR is equal to I line, and IB minus IY is equal to I line. Clear? And in the same way, IR equal to IY equal to IB equal to I phase. Okay. Now we will establish a relationship between line current and phase current. Look, here one thing can be noted, that the difference between these two currents is 120 degree. Here this whole angle was 120 degree. So when I will draw this IB in the opposite direction, then it will be in the middle of this IR and IY. So this angle will be 60 degree. Now this resultant IR minus IB is also in the center of this, so this angle will be 30 degree, and this angle will also be 30 degree. Clear? This thing you should note. Now let me draw the line current. So what will be the relation of this? Again, using parallelogram, IR minus IB will be equal to under root IR square plus IB square plus 2 IR IB cos. What is angle between these two IR and IB? 60 degree. So cos 60 degree. Now this is your IL under root IPH square plus IPH square plus 2 IPH cos 60 is what? 1 by 2. 1 by 2 and 1 by 2 will get cancelled out. So it will become IPH square plus IPH square plus IPH square. So it will be equal to 3 IPH square under root. So it will be root 3 IPH. IL will be equal to. So this will be the relation for line current and phase current. And what is relation between line voltage and phase voltage? VL is equal to VPH. This is your line current and line voltage. Now what will be the power? Same as in star connection. Phase power will be equal to phase power is equal to 3 times multiplied by per phase power. So it will be equal to 3 into VPH IPH cos phi. Now let us convert this phase power into line power. So at the place of VPH, what we can write? VL as it is, and at the place of IPH we can write IL by root 3. IL by root 3 cos phi. So it will be equal to root 3 VL IL cos phi. This is your line power. And what was phase power? PPH equal to 3 into VPH IPH cos phi. Clear? So this is the scenario of voltage and current relationship and the power. Now let us solve a numerical so we can get more through this star and delta connection. Let me write a question. A balanced three-phase delta connected load has per phase impedance of 25 plus j40 ohm. If 400 volt three phase if 400 volt three phase AC supply is connected to this load, find first one phase current, second is line current, and power supplied to the load. Third is power supplied to the load, power supplied to the load. Clear? So first of all, let us solve ZPH. ZPH will be equal to, here it is given that impedance per phase. So we have to calculate just the magnitude. What will be the magnitude? 25 square plus 40 square. So it will be equal to your 625 plus 1600. So it will be equal to 25. So the value will come out to be 47.17 ohm. This is your ZPH. Now what will the value of IPH? IPH will be equal to VPH upon ZPH. As we know, here the voltage VL is given. VL is equal to 400 volt, and in delta connection it is given that delta connected load. So in delta connection, VL equal to VPH. So it will also be equal to 400 volt. So 400 upon 47.17. So the value will come out to be 8.48 ampere. Clear? Now, what will be the value of IL? IL equal to root 3 IPH, as we have previously obtained. The current will be equal to, line current will be equal to root 3 times of phase current. This is the expression. So just multiply this phase current into root 3 multiplied by 8.48. So the value will come out to be 14.7 ampere. What will be the value of power factor cos phi? Cos phi equal to R upon Z, so it will be equal to RPH upon ZPH. What is RPH? 25 ohm. Z is given, ZPH is equal to 47.17. So the value will come out to be 0.53 lagging. Now power consumed, you can find root 3 VL IL cos phi, or you can find 3 VPH IPH cos phi. Whatever you want, you can find by using these two formula. Here Z is given like 25 plus J 40. So basically it will be R plus J XL. Clear? So from here we can obtaining the value of R. We are using value of R. So don't get confused that where R will be obtained. Here it is already given that Z equal to 25 plus J 40. So it will be equal to R plus JXL. And if it was given like Z equal to 25 minus J 40, then R minus JXC. It will be your Z. Clear? There should be no doubt between these two terms. Okay, let's do one more question. A balanced three-phase load consists of three coils, each of resistance 6 ohm and inductive reactance of 8 ohm. Determine the line current and power absorbed when the coils are when the coils are star connected, delta connected. First is star connected, second is delta connected. Clear? And voltage is given, V is given 400 volt. Okay. Now first we have to find the value of Z. Z will be equal to what? It is given that the resistance is 6 ohm and inductive reactance is 8 ohm. So it will be equal to 6 square plus 8 square. So value will come out to be under root 100. So 10 ohm. It will be a Z. Now first of all let us take star connection. In star connection, we know that VL will be equal to root 3 VPH and IL will be equal to IPH. So first of all, we have to find the VPH, VL upon root 3. So it will be equal to 400 upon root 3. The value will come out to be 231 volt. Now current will be what? IPH will be what? VPH upon ZPH. So 231 upon what is Z? ZPH is equal to 10 ohm. So 23.1 ampere. It will be your IPH. Then IL will be equal to IPH in star connection as I have already told you. And what will the power? P equal to root 3 VL IL cos phi. So what will be the value of cos phi? Let me calculate it here. Cos phi will be equal to what? RPH upon ZPH. RPH is what? 6 and ZPH is 10. It means 0.6. Then phi will be equal to, or simply you can say cos phi is also, we have to use directly cos phi. So nature will be lagging because load is inductive load, inductive and resistive load. So root 3 into 400 into what is 23.1 into 0.6. So power will come out to be 9602.5 watt. It will be your power. Clear? This is all about the star connection. Now we will go for with delta connection. Okay. Now in delta connection, VL equal to VPH and IL equal to root 3 IPH. Now, what will the value of IPH? And VL equal to VPH equal to 400. Then IPH will be equal to VPH upon ZPH. So 400 upon 10. It will be equal to 40 ampere. Then IL will be equal to root 3 IPH, then root 3 multiplied by 40. So value will come out to be 69.28 ampere. Now what will the power? P will be equal to root 3 VL IL cos phi. Again power factor will be the same because cos phi will be equal to RPH upon ZPH, so it will remain same, 0.6 lagging. Now put the value, root 3 multiplied by 400 multiplied by IL is what? 69.28 multiplied by 0.6. So power will come out to be 28799 watt. This will be your power. Clear? So it is all about the star and delta connection. Here one thing you can note that in star connection, in star connection line current was only 23.1 ampere, and in delta connection line current is 69.28 ampere, almost 3 times of the line current is more drawn in delta connection. So delta connection demands more line current as compared to star connection. This current is in case of delta and this current is in case of star. Clear? So you have to know about this, and at this way, at this point I should stop, and this is all about your star and delta connection. So in our next lecture we will start how to measure power in three-phase system. There will be three different methods: 1 wattmeter method, 2 wattmeter method, and 3 wattmeter method. Our main focus will be on 2 wattmeter method. Okay, thank you so much.